Hello there, my name is Darwin, and in this video I'm going to be demoing my final project for CPSC 426 Building Distributed Systems. So for my final project I worked alone and I created something that I called the Kubernetes Herodotus scheduler. So what this is it's a modified Kubernetes scheduler process that aims to improve transparency and observability in the pod scheduling process. It's broken into three different components. There is the kube scheduler binary, which I have created and built off of the Kubernetes source code. An HTTP server metrics endpoint that I wrote in Python, which exposes the metrics that the modified kube scheduler binary collects, and an extension to the kubectl command line interface that allows any cluster operator with this program installed to interact with the metrics endpoint and read back the data in a human readable manner. So first off, I'm going to show off the cluster that I'm working with and also some of the stuff in my repo that I'm going to submit. So I'm running this right now on my personal computer running Windows in a WSL Linux instance, and the Kubernetes cluster I'm using is micro K8s. So I'll just show. Oh, I have it built in. I changed my kubectl to refer to the micro K8s cluster. So I can just do kubectl get node just to show the cluster I'm working with. So Darwin main is my personal computer, and then these two nodes are running in VMs in multipass, also in oh, I'm sorry, not in WSL. These two VMs are running on my host computer in multipass. So that's the cluster. And then for my repo, I'm here in the root directory of my repo. And then now I'm going to show off the kubectl plugin extension. So I already have it installed, but if you want to install it, all you need to do is run this install script that I made. All it does is just copies the Python program into your path. So when you run kubectl, it will know where to look to find this plugin. So I've already done this, so I'm not going to run it now. But as you can see, if I do kubectl Herodotus, then things pop up, and this is the output of my program if you don't input any correct command line arguments. And you can see there's a help message, and we can expand this help message by giving the -h flag to kind of see exactly what this is all about and see all of the optional arguments that exist as well. So now let's look at basic usage of this entire system. So right now I have a stock Kubernetes cluster that nothing is running on it right now. So what I'm going to do is I'm going to apply the Herodotus scheduler program that I've conveniently put in an entire YAML file. So I'm just going to kubectl apply the Herodotus scheduler. And so while that is creating, I can briefly explain what this is doing. So this is just creating all of the service accounts and config maps that are necessary to run this program. The two important things to look at are these two deployments right here, the Herodotus scheduler and then the Herodotus endpoint. This scheduler is the custom binary that is built off the source code, and then this endpoint is the Python HTTP server. Let's see if those have finished, and all of these are applied in the kube system namespace. So let's see if that has finished yet. Great. So we see the scheduler and the endpoint are both running successfully within the kube system namespace. Let me see. Let me pause this real quick because I realize I need to show off my VS Code as well, and right now it's only recording my terminal. Okay, I'm back. I hope that wasn't too jarring. So now I'm going to deploy a test pod to see what this looks like. So right here I have this YAML file that all it does is just deploy a single pod. And you see right here, the important thing is that I specify that I want to use the Herodotus scheduler. And if I don't do this, it will run on this pod will be scheduled using the default scheduler, which is still running in the cluster. And I don't want that because I want to showcase my project, so that's why I have that there. So let's apply this. Deploy default pod. Oh no, did I misspell something? Oh, sorry about that. All right, so we can see that pod test1 has been created. Let's just confirm that. And it has. It's been created under the default namespace. And then now let's take a look at the Herodotus commands we can run. So one of the Herodotus kubectl interface has two subcommands. We can either query searches against a pod or a node. So let's look at the pod that we just created. As you can see, when you run this, it will spit back a bunch of info about the scheduling process that just occurred with this pod. So during the scheduling process, we can see that all the filters have passed. We didn't specify any any specific constraints on this pod. It's just a default pod, so this makes sense that every single node was available to schedule this pod. And then here is where we can see the breakdown of all the scoring filters. So this determines which node the pod will be placed on. The highest scoring node will win, and the Kubernetes system will choose that node. And so we can see that Darwin main here is has the highest score with 482 compared to 458 from the other two nodes. And we can see the breakdown of why we got to 482. And it's because really quickly looking, we have the same taint toleration and same pod topology spread across all three nodes, but the Darwin main has scored higher in the node resources fit and node resources balance allocation. In these filters. This makes sense. So these two filters score nodes based on how much resources they'll use up and how spread out the resource usage will be. And since this is literally just my host PC, I have a lot of resources to spare on this node, but these two other nodes are VMs that only have 2 gigabytes of RAM each and one virtual CPU. So obviously they are a lot less powerful, and so it makes sense that they scored less. And we can see that the placed node was Darwin main, and the reason was because it had the highest score. Now, let's look at the node view. So we can choose the node subcommand, and now we can choose any node to query. So let's look at Darwin main. Now we can see every single filter that has been run on this node. So these are all the filters that determine whether a node is schedulable or not during a scheduling cycle. And then we can also see the eligibility rate. So we've only run one pod so far, and it was eligible to be scheduled on this node, so it's 101, 100%. We can see all the score that has accumulated so far, and right now it's just been one scoring cycle, so it's just the 482 from that previous cycle. And then we can see the scoring breakdown for all these nodes. We can see all of the scoring plugins breakdown for this specific node. Now, if we take a look at one of the VMs, let's do node 1. We can see it's the same thing over here. Now, this is pretty cool, but it doesn't really show anything too interesting right now. So let's deploy some more pods. So I have another pod. This is the main label pod. So here it's basically the same pod, the same test image with the same scheduler specification, but now I have a node selector that's saying I only want to place this pod on nodes that have this label, the CPS 426 label main. I can quickly show what the node labels look like on my cluster. As you can see, I have CPSC 426 label. For the two microcades node, for the two VM nodes, they're labeled micro, and then for my main host computer, they're labeled main. So by specifying that I want this to be placed only on the main nodes, this should only place this pod on Darwin main. So let's see what happens. Let's apply this pod. All right, make sure that is, yep, there we go. It's successfully run. So now again, let's take a look at the pod breakdown real quick. And now we see there's some more interesting stuff. So if we look at the node filter statuses, we can see that for Darwin main, all filters passed, so this was an eligible node to be scheduled on. But for the two other VM nodes, we can see that there's a failed filter now. And this is the node affinity filter. So this filter checks to see if the node matches the labels and the affinities matched in specified in the YAML spec. And obviously, as I just explained, these nodes don't match that. And so it failed the filter and it was ineligible to be scheduled on. And since we already failed a single filter, we don't need to run these other filters. So these other filters are skipped. Um, and then Kubernetes is pretty smart. So since there's only one node available to schedule on, it's Darwin main, then it doesn't actually run any scoring filters either. So that's why none of the scoring filters metrics are populated. And so we know that Darwin main was chosen just because it was the only one available. And we can see that reflected in the reason tag here. Now let's take a look at the node view. Let's take a look at the node view for Darwin main. We can see everything makes sense. 2 out of 2. This is we just scheduled this other pod, so it's 2 out of 2, 100% eligibility rate. These statistics, these stats. Oh, and sorry. And since we didn't do any scoring, none of these scoring metrics increased, and we can see it passed every single plugin again. But if we take a look at one of the VM nodes, we can see, oh, now we actually one of the pods that went through a scheduling cycle on this node failed, so we have a 50% eligibility rate. And you can see right here that the node affinity plugin has the 50% pass rate. All these other ones are still 100%, and of course we don't count any skipped plugins. So that's how you can see like sort of the decision-making process that the Kubernetes scheduler, once it's doing, and you can see why it chooses to choose specific nodes over others. So these have been pretty basic examples, but let's take a look at something more complex. So I have a big deployment that just has the same test pod, but I want 50 replicas of this pod, and I specify a node affinity, which using this preferred during scheduling, ignored during execution affinity tag with this using the micro label. So what this means is that this deployment should prefer nodes that should prefer the VM nodes, but it would still schedule this pod on my host Darwin main node if it needs to. So let's run this and let's see what happens. And then if we get pods in the default namespace, we can see all of these deployment pods creating right now. Let's give it some time to spin all these pods up. All right, that looks pretty good. Cool. So let's take a look at the node view first. So if we go to Herodotus node and we go to the VM node, we can see all these stats have shot up, and all of the plugin filter breakdown, scoring breakdown stats have shot up too. We're 51 out of 52 pods eligible, so it's 98%. And we can see all the score that the node has accumulated and the average score per scheduling cycle. So it's around 476 per scheduling cycle. Now, if we take a look at, let's take a look at a single pod that was deployed. So I'm going to choose one at random. Let's just choose this one right here. So if we go to kubectl Herodotus pod and the name of the pod, then we can see the scoring breakdown. And this is interesting. So this was placed on the VM node, microocades node 1. And let's take a look why. So we can see here that under microocades node 1, the score was 487, and this was partly because the node affinity plugin really boosted this node and gave it a really big sort of boost in the ranking. And this is exactly the preferred during scheduling, ignore during execution node affinity right here. So we can see that for Darwin main, even though Darwin main has a higher node resources balance allocation and a higher node resources fit, 99 and 62 versus 87 and 0 respectively. This node affinity, this 100 score from this node affinity plugin was high enough to overshoot this above Darwin main and have it be placed on this node. And we can see the other VM node has the same exact score. So Kubernetes just kind of picks one of those two. It doesn't really matter. Um, so yeah, that like as you can see, these have been pretty basic examples. But if you have a very large cluster with tons of nodes and tons of pods and tons of deployments being um, applied and removed on day to day, it could be quite confusing to sort of figure out what's placed on what and why. So this tool is a diagnostic tool meant to help cluster operators sort of kind of understand what's happening underneath the hood. And it's basically thanks to this custom, as I said before, the custom kube scheduler binary that I modified using source code, the HTTP server endpoint that exposes the metrics from the custom binary, and then this kubectl Herodotus plugin that I created, which displays all this information in these nice tabular form. Um, so I hope this demo wasn't too long. Obviously, the exact sort of implementation details and like my thought process is going to be in the write-up, and the exact installation details and sort of how to run this is going to be written in the README. So everything will be in the README and the write-up for this project. And this was just sort of a live demo to show what my plugin is capable of. So yeah, thanks for watching, and have a good day.